Hello, my name is Christopher. I'm a senior developer at AiQu, and in this video I will show you the jobs table, which gives you an overview of your historical jobs and jobs that are running and the jobs that are good for running in the future. Uh, so, as we can see here, I have two jobs in my job table. One that was cancelled a couple of hours ago, and one that is running. Um, and if we look at the first column here, we can see it's the job label, which is simply the name that you give your job. In my case, I just put test job, but usually it's some kind of a description of what your job is supposed to do. And this second column is the user that started the job. In most cases, it's your own user, but if you are part of a project, it can be other project members' job if it's started with the project that you are a member of. And the third column is image, which is the Docker image that is used to sort the job. In my case, I've used the NVIDIA TensorFlow image, which is pulled from the NVIDIA container registry, as we can see here. They have a large selection of AI optimized containers. That's a pretty good choice to use for this kind of workload. And the next column is the status, which simply gives you an icon for what status your job has, if it's running, if it's cancelled, and so on. And the time column gives you, in the running jobs case, it's the time remaining for the job. And if it's cancelled, then it shows you the time when it was cancelled. And you can also see that there's a button here if the job is running, which is the extend time button. So if you have only 1 hour left and you feel like you need more time, then you can simply extend the job. Just put down 2 hours if you need it, and then click extend. It is not guaranteed to work, since there can be other jobs that are running and that has booked the same GPU that you are on. But if it's possible, then it will extend. And the column here, the usage column, is the GPU usage that the job is consuming. So if you have two GPUs and you are using them both 50%, then it will be 50% here. And for the cancel job, there's of course no usage. And my job isn't actually running anything in it. It's just started, so there's no usage for it right now. And the final column is the actions. It is things that you can do to the job, or actions that you can take. For example, this here is the terminal, which starts a web session to the container that is running. So it looks like this. You get dropped into a terminal for that container, for that job. So if you need to start a process or do any kind of work, then it can be done through here. And this button is more actions that can be taken. It's the Jupyter. If you have a Jupyter running, you can click that and get dropped straight into the Jupyter, and you can also cancel the job. So we can also have a look at the job details, which you get by just clicking on the job. I'm gonna start with the cancel one and show you what information is available inside that, and then compare it to the running job. So here we can see the first few fields have the same information as the table, but there's also a few that aren't available. So this one, for example, is the node name, which is the node that the job was run on. So in our case, it's a DGX 100, A100, and it was queued with the default queue. And a queue is simply a collection of nodes. It can be 10, 20, 500 nodes that when you queue a job, it gets put in a queue, and then one of the nodes inside it will accept it. In our case, we only have one node, so that's the only one that was available when I queued it. The registry is the Docker registry that was used to pull the image. So in this case, it's the NVIDIA container registry, and the image was the NVIDIA TensorFlow one. We also have an estimated start time, which is when AiQu will actually start the job. It will at least get started with starting the job. There's always some delay since the image might have to be fetched, and this TensorFlow, for example, is a pretty large image, so it can take a few seconds or a minute, maybe more than the estimated start time if the image is not available. But this is at least when AiQu will try to start it. We can also see what folders we had mounted inside the container. So this is the external storage that was used. We have the Pure Storage FlashBlade with my home catalog inside the users bucket. And it is mounted, or was mounted, in the container to /data. So if I would have a look inside the container and look inside /data, I would see this storage. And we can see here inside the files the same storage structure. So in the home catalog, I have the AiQu utils folder and with a bunch of scripts. So that is the one that would have been mounted, and if I had any kind of output from a job, then I could put it here and it would be saved for later. The next part is the resources that I had available, that I had queued the job with. So I had 1 GPU, 4 CPU cores, and 128 gigabytes of memory. The next part is the job environment, which is environment variables that you might set for the job. We have a few different settings here. You can just put on a job environment and then use it inside the job, or you can put one environment that gets deleted right after the job is completed. So for example, if you want to put a password and then not save it anywhere, then that's the choice that you can make. I just put a flag in it that it should be deleted right after the job is completed. The GPU usage graph is how the GPU that was assigned to you was, how much it was used during that time. For my job, I had nothing running, so there's no usage, but I can show you later in a different video how it will look when it actually gets some usage. We can also see that it was GPU number 5 that was assigned to it. We have the tokens spent. which is tokens are the currency that we use here in AiQu. It's virtual currency, not connected to any kind of real currency. It's just a way of budgeting the jobs and availability of the GPUs and system. The 5 is the base cost for running a job, and then each minute there's additional tokens drawn based on how many GPUs, CPUs, and memory that you have. And then we have some information about when it was queued, when it was actually started, when it was supposed to be terminated, which is the job length that I had, and when it was actually terminated. And this is a different time since I canceled it on my own. We also have the job log, which shows you the output from the container. In my case, it's just the TensorFlow output that is the default from the NVIDIA TensorFlow image. But if you have your own custom image, you can start it with a process that logs your progress in a job or something similar. And then you also have the clone job button, which is you can take everything that was included in this job and then just put it in the queue job page, so it can easily be replicated again. So I can show you how that looks. If I click clone, then it puts all the parameters that I had chosen for that job into the add job queue. I'm not gonna queue a job, that is for a different video, but could be good to know at least. So if we have a look at the running job, it's pretty similar except for these two fields. One with the edit fields, which you can use to edit any kind of parameter that you have, or not any parameter, but a few of them at least. You can see that the job label can be changed, as well as the Docker image, the ports, and even the folders mounted to it. A lot of these will require a restart of the job, since if you choose a new image, then you would need to restart it. It can't be changed directly. It needs to be stopped and then restarted again. And then we also have the restart job button, which you can use if you for any reason need to restart the job, or maybe if it has failed for some unknown reason, then you can restart it. And you also have this, the port, which can be used to open a port to the container. Right now we have defined that 8888 should be running inside the container. So if I want to open it, I can open it in a few different ways. I'm gonna go more into depth with these options in a later video, but for now you can just know that you can open the port here. So that was all I wanted to show you in this video. Thank you for watching.